our seminar. It's our fourth session. So today, the first presentation is in charge of Professor Lotti Shaivi from the University of Tangier. He belongs to the National School for Applied Sciences, and at the same time, Professor Shaivi is currently the president of Moroccan Association for a Sustainable Environment. So I pass you the floor, Mr. Shaivi, and you can start, please. Thank you for being with us. We are very proud of having you here because we know that you are an outstanding scholar in these issues and close to us, Morocco, and I would say, additionally, I would say that the University of Tangier for us, for the University Autonomous of Madrid and AMENET, the Africa, Mediterranean, and Europe Jamon Network, we are a great and an excellent panel. We are very proud of it. So thank you very much, additionally, for these aspects to take into account. So I give you the floor, please. Please, could you turn on your micro? Huh?
Yes. Okay. Sorry. Okay. Thank you very much, Professor Mella, for this introduction. And I'm very pleased and honored to be a part of this training online activity. And as you said, I think that's our partnership with the University Abdelmalek Sadi and University Autonomous of Madrid is of a long time and has also a bright future. Well, so my seminar is after exchange with Professor Milland also is to talk about circular economy as a response to climate change. And the idea is how we can see that this concept of circular economy can be a really and a good response to all these climate change crises. So my contents, the contents of will be, I will briefly talk.
Please, would you mind sharing your slides? Because we cannot watch them. We cannot watch them now because
you shared. Is it okay?
Yes, that's it. Okay.
Okay. Thank you.
Okay, thank you.
Okay. So I will begin by talking about some few words about the actual climate crisis context, especially when you are in the next days will be at the COP26. And I will introduce the circular economy, the concepts, the principles, the key characteristics, and also what can we call the enabling factors if you want to succeed a circular economy model. And then we conclude, which is very important for exchange, some Moroccan models of this circular economy. Well, first thing is that we know that now that our take, make, waste linear economy is heavily extractive. Our model of consumption, our model of producing is linear and is resource intensive and produces greenhouse gases that are causing the climate crisis. Companies extract materials from the earth, apply energy and labor to manufacture a product and sell it to an end user who then discards it when it no longer serves its purpose. So this linear approach, which relies on fossil fuels and doesn't manage resources such as land, water, and minerals for the long term, and emits greenhouse gases that causing these global climate crisis. So to have an idea about what is the order of this quantity of greenhouse gases. So generally, greenhouse gases are measured in carbon dioxide equivalents. And today we collectively emit around 50 billion tons of dioxide carbon equivalents each year. So this diagram will give us an idea about the global emissions distributed by economic sectors. So we have the different sectors, different energy sectors as energy systems, energy for transportation, energy for buildings, and on the other hand, we have also greenhouse gases caused by industry activities, and AFOLU means agriculture, forestry, and other land use. And if we make a quick calculation, we consider that 45% of our greenhouse gases are from the production of goods and management of land. So behind this, we have our linear economy, this linear economy model. And of course, so to think to an action, 55% we can, because all the discussions now is about how we can produce energy, how we can use energy to move to renewable energies, but if it should be necessarily completed by also to move or to rethink our way to make the production of goods, and we do also our management of land. Well, so according to these percents and these numbers, the climate crisis context can be today. Is this okay for the slides?
Yeah, it's okay.
So despite commitments to that effects being made by the 195 countries that signed the Paris Accord, what we can conclude today? We conclude today, and I make reference to Greta Thunberg as a symbol of the civil society for their that urges countries and leaders to make more efforts and to make more coordination, because there is an urgent need for this climate action, because the global greenhouse gases is not yet being done. We are still not close to being on track to the temperature rise to 1.5 degrees in 2100, with what we said, or what it was approved in the Paris Accord. And we can also conclude that current emissions show no sign of peaking anytime soon, and are instead leading to an increase of 3 degrees or even 4 degrees if doesn't change our energy system. So what we have to do, so you need, as I said, urgent coordinate action, and far-reaching transformations will be needed. So these far-reaching transformations can be, first, we have to increase our ambitions. And today, scientists and experts consider that we have to multiply by 5 these ambitions, namely the NDC, the nationally determined contributions for climate change, and in order to meet the emission targets consistent with the 1.5 degrees. We need also a decarbonization of the energy system, and we need to accelerate it by introducing more renewable energy and energy efficiency in industry, also in buildings and in transportation. But another thing which is very important, and this is the aim of this seminar, is that we need to transform also our way to produce goods and how we can use the land. So the idea is how we can move. We need to move to another model, okay, which is from linear economy to a circular one. And we have to change this idea of just make waste by using and a reuse of resources. So in a manner is we have to redefine this economy as a closed loop, and we will see how we can close this loop. It's not, the idea is not just we have to recycle at the end of the process, but we have to be more, we design another way of economy. So what is circular economy? And circular economy is, first, it is an economy. So it is an economic model. It is very important. And this is an economic development designed to decouple growth from finance. So it is related and connected directly with the sustainable development concept. And it is an economic approach which can design to benefit at the same time businesses, society, and environment. So it is an approach which offers a positive way forward by redefining value creation to focus on society-wide benefits. Okay, what are the principles? Circular economy relies on 3 principles. And the first principle is design out waste and pollution. So it's, as I said, that it's not concerned with just at the end of the process of recycling. But the first principle is very important because we have to think circularity while we are designing our products and our goods. So design out waste and pollution. Second principle is how to keep products, components, and materials at their highest value and in use, so to extend the lifetime of our products. Third principle is regenerate natural systems. And I will give more details about how these principles can be practiced by giving and by describing the characteristics later. So what are the benefits of such a model? We can share, according to the European Environment Agency, they share the circular economy benefits on four categories of benefits. First, the first benefit, which is natural, is economy. Economic benefits, that makes new opportunities for growth, and also for innovation. Because in this, which is very important in the approach, it's an approach that we can well earn and well manage, and to be efficient in also from the point of view of social benefits, because we can introduce with such a model, we can build a sustainable consumer behavior, and which is very important, and also to create new job opportunities. And the last 2 type of benefits are of great importance, and it can be as a response also of the climate change crisis, is the resource benefits, because improving resource security and decreasing import dependency. I think that the pandemic COVID shows us the problems, such problems of the availability of resources in some countries. And the problem of import dependency, I think it's one of the most today problems in the company. Some companies, without availability of resources, we cannot, of course, be in development. And circular economy can give us also an answer about this, because we are decreasing this, we can decrease this import dependency. Environmental benefits, of course, with such a model, we will get less negative environmental impact and less emissions. So what about how we can, a circular economy gives us or produce less emissions? So if I come back to the three principles of the circular economy, we can have three actions or three manners to reduce these greenhouse gas emissions. From the first principle, we reduce globally the greenhouse gas emissions across the chain value, whole the chain value, because it's not concerned, as I say, of the last step of the process, but in the whole chain value. For the second principle, we can retain, it's allowed to retain the embodied energy in products and material. And for the third principle, once we regenerate natural systems, carbon in soil and products. Experts say that a circular economy approach could reduce global dioxide carbon emissions from just from K industry materials by 40% at the horizon of 2050. And don't forget that the most important is to reach the neutrality of carbon. So such a percent is of great importance. Another benefit, more transversal, general, is you can say that circular economy is a roadmap, can build a roadmap towards the SDGs, the Sustainable Development Goals globally. And we can show that at least 10 of the SDGs are concerned and with the circular economy. It means that the circular economy contributes directly to at least 10 SDGs. And we can say, for example, the main one is responsible consumption and production. Okay, but once we are talking about the principle of regenerating natural systems, so we are talking about life below water, life on land, climate action, of course, because it's reducing emissions. And for the benefits, economic benefits and social benefits, it can also contribute to industry, innovation and infrastructure, and also sustainable cities and communities, good jobs and economic growth, and reduced also inequalities. Of course, partnership is very important, and I will talk about this in it will be one of the enabling factors about to succeed a circular economy model. Well, now what about the characteristics? So according to these principles, we can characterize a circular economy model by 5 key characteristics. I will talk about this. I will summarize for each characteristic what is important, and we can check with this regarding to these principles how we can make in practice a circular economy approach. So 5 characteristics. First, less input and use of natural resources. 2, increase share of renewable and recyclable resources and energy. 3rd, reduced emissions. 4, fewer materials losses, residuals. And 5 is keeping the value of products, components, and materials in economy. And you will now give some details, an idea about each characteristic and its importance how it is complementary with the other characteristics. So when I'm talking about circular economy, we need to talk about natural resources and less input and use of natural resources. And for this, one thing is important. When you say less input of natural resources, it means also that we make focus on efficiency. Less natural resources doesn't mean less quality. No, the idea is how we can minimize and optimize exploitation of raw materials while delivering more value from fewer materials. See, the idea is to have more from few, okay, with an efficient, so we have to make an efficient use. Reduced import dependence on natural resources, which is an important stake for all the countries and for also the companies. Efficient use of all natural resources, as I said, and minimize overall energy and water use. And we can say when you are talking about natural resources, is about energy and also raw materials. Second characteristic is increased share of renewable and recyclable resources and energy. And the idea is to create like a symbiosis, okay, a synergy between all the partners about resources and about energy. So first, no renewable resources replaced with renewable ones within sustainable levels of supply. It is in accordance in the vision of the climate action for using more and more renewable energies. Increased share, and this is which is new and more important, increased share of recyclable and recycled materials that can replace the use of virgin materials. And this increased share means that you can, for example, that the waste of a company can be the raw material or the inputs for another one. And this is the idea out of sharing the recyclable and recycled materials. Closure of material loops and sustainably sourced raw materials, which is, as I say, can be in the same company and or in sharing with the other companies. The third characteristic is reduced emissions. So I talked about this in the previous slides. And the idea is the reduced is through the full material cycle, okay, by using less raw material and sustainable sourcing. For material losses and residuals, the idea is how we can build up of waste. The buildup of waste is minimized, to minimize the waste as much as possible. It means that to increase the recyclability or the circularity cycle in order to minimize waste. As a consequence of this, to minimize also incineration and landfill. The idea is how we can get to be closer to the zero landfill, and dissipative losses of valuable resources also are minimized. Finally, the fifth characteristic is to keep the value of products, components, and materials in economy. So to extend the product lifetime, keeping the value of products in use, reusing of the components, and also how can the value of materials preserved in the economy through high quality recycling. So this is these 5 key characteristics. We can check of this the quality we can say of our circular economy model. A circular economy model can be characterized by these 5, and you can put also, as I will say, in the enabling factors indicator to make an assessment of the project as if it is a circular one. Now let us talk about the enabling factors. So Now, according to the characteristics, we can say that the transition to a circular economy requires fundamental changes in many different areas of the current social economic systems. It is, we know it can be a complex, agreed as a complex process that is difficult to predict. We have lots of parameters to manage. And several crucial areas of change can be identified in technical, economic, and social domains. So here are 5 enabling factors that can guide and accelerate the transition process. And they were described in a report by the Europe Environment Agency. And the idea is that these factors need to act is addressed to companies, to also to the leaders, to make and to build up a circular economy model. And these factors should act with a simultaneous manner in order to create the effects expected. So these enabling factors are of 5. First, eco-design and eco-innovation, repair, refurbishment and remanufacturing, recycling, business models, governance skills, and knowledge. So for the first factor is of great importance. It's the main one because it is concerned with the eco-design and the eco-innovation. It is concerned also with the manner how we design our goods and our process production. So how we can have to think the reuse of components products designed for a longer life. And I think that this is in a society of consumption, it's a very problematic that we have today goods more and more than a shorter life and not a longer life. Product design based on the sustainable and minimal use of resources, on how to optimize, okay, high quality recycling of materials at the end of a product's life. And when I'm talking about innovation, it can be with a technological innovation. We need technical innovation, but also an organizational one, because we cannot, for many times and for many cases, circular economy will be concerned not with one company, just one company, but it needs an ecosystem. It needs a territory that can be managed with such an approach. Repair, refurbishment, and remanufacture. We have to give priority to such actions which can enable to reuse of products and components. So it's concerned with also the consumer behavior and to think to the repairing, to the refurbishment of the goods and the products. It's also a state of mind. It's a mindset. Factor 3 is recycling. High quality recycling of as much waste as possible. Use of recycled materials as secondary raw materials and well-functioning markets for secondary raw materials. We need an infrastructure to also to make markets, to open markets for secondary raw materials between companies, between industrial companies and in the same territory. Factor 4 and 5 are in my sense, of the most important because sometimes we can, for example, show the importance of from the point of view technique or from the point of view scientific. But if we don't have behind this efficient business model, we cannot make in practice our model. So we need new business models that can respect and can make in practice such approach. It is based on focus on offering product service systems rather than product ownership. This is one of to change this also point of view of the ownership. Collaborative conception means that we need also an industrial symbiosis, collaboration between companies, provide the West, and of course, to build a win-win model in order that each entity should be a winner in this and take interest and profits from this approach. Byproducts of one become a resource of another, and this is the idea, the main idea that can be we have to make and practice in industries. Last factor is concerned with governance skills and knowledge. First of all, what is most important that is the awarenesses, raising about changing lifestyles and priorities in consumption patterns. And I think that it is a shared responsibility of all the society as a producer, but also as a consumer. These awarenesses that to produce differently and to consume also differently. Second thing which is important is the participation in the implication of all the stakeholders and interaction and exchange of experience around this approach. And the idea is also to go for a win-win model for all the stakeholders. Education it's important, and it is, I think, essential. And when I say education, it means also competencies. We need today, our society and our industries needs more competencies in circular economy, in engineering, in managing energy to make and success this circular economy. When I'm talking about competencies, local competencies, when I'm talking about, for example, a country, we cannot import an economic circular model. We have to create our own one because it will be as an answer of the characteristics of the territory. Finally, data monitoring and indicators. We need monitoring of all the indicators. We need also to compute. As we say, for example, an approach to compute, for example, reduce the quantity of reduced emissions. We have also indicators to improve the approach, because the approach should be in a continuous improvement to improve also the circularity of our products and goods. Okay. According to these enabling factors, what can be the first, if you want, the first step to make on a way a circular economy process? So here I make just the first steps how we can imagine a circular economy process in such a territory. When I say in territory, for me is it can be a local community, a city, an industrial zone, or a group of companies. So first thing which is important, as I said, is that we have to build a contextual and approach. This is very, very important because it depends, the circular economy depends on the resources that are available in this territory and the kind of activities. And it's changed and differs from a territory to another one. Life cycle management of products and activities is of great importance in order to identify what? To identify waste mapping, how we can improve, how we can, for example, making recycled actions, how we can also identify raw materials, recycled raw materials for other companies. And last thing, which is also important is to identify the stakeholders that are concerned approach and to imply them all in order to have an efficient circular economy. Generally, circular economy needs also an infrastructure. We cannot, for example, one company, it can make some special efforts, local efforts, indoor of its industry. But if you want to have a circular economy of high effects, we need to imply also the local community. We need also to make an effort how we can make a process that all the stakeholders are involved. Okay, so this is first an idea about circular economy, concepts, principles, some characteristics, and enabling factors of success. Now I will conclude by talking about Morocco. And what about circular economy in Morocco? Morocco is considered today as an emerging economy, well developed. We have making a lot of efforts in energy policy, and also there are many of programs of decarbonation. I show you here we have, for example, a national strategy of environment and sustainable development with 7 stakes, and the end of, or the main objective of this strategy is to have an inclusive green economy and a circular economy. And from this strategy, a lot of programs and several programs has been launched for decarbonation, especially for small companies, and also in making encouragement startups in circular economy. I will give 3 examples from 3 different entities. So the first one will be concerned with Groupe Renault. Groupe Renault in Tangier is Renault, so it's manufacturing cars, and it is a great site. Just to give you an idea about Groupe Renault, today there are more than 9,000 employees, and manufactures 400,000 cars per year, each year. So it is a great project in the north, in Tangier, in the Mediterranean, for the Mediterranean side of Tangier. And they have one of these examples. I took this picture in the factory. So Renault uses biomass to produce the thermal energy for its painting department. So we can say here a nice look, which is very interesting. So Renault has 2 biomass boilers to get the thermal energy, and these biomass boilers are worked with the olive pits and with crushed wood. Crushed wood is from the pallets they have locally. So just to have an idea, it's about 5,000 tons per year, which is a great quantity, and also from olive pits that came from the olive trees agriculture from the north of Morocco. It's not so far from Tangier. It's from especially the region of Ouazzane. For our friends that they know Morocco, Ouazzane, it's also in the north, and there is a great activity of olive agriculture. So from this, we produce energy. Then, of course, there are waste of ashes from the post combustions, which can be also used and sold to be an agriculture for fertilization. In a global manner, in Group Renault, this is a presentation from a presentation that has been exposed in one of our activities in the AMED Association of Sustainable Environment. So the director of Renault exposed this and provides us this map to understand how circular economy is applied. So it is a site of carbon zero. They consider that 98% of emissions are avoided using and thanks to the biomass, renewable energy, and so on, reusing water and all this. And then we also, the 2% are on offset carbon. And we can say, so here, it is a complete, for me, it is a complete interesting example, because at the same time, we have the using of renewable energies from aeolian that are in the region, and the biomass also gives the thermal energy. So it is we say that it is an interesting example of circular economy. Second example is, will go with us to city of Fez. Fez city, it is in the center of Morocco, a spiritual capital, and it is the second city in residence, in terms of residence after Casablanca. So in Fez city, it is enlightened using biogas energy produced from waste. Here we have a company which is Group Ecomed that's managing landfills, and thanks to the biogas energy, it is produced from waste to provide more than 25% clean of renewable energies from just waste. And this Group Ecomed, it is sharing this experience in also many of other cities, other examples of biogas cities, also in different region in Morocco. Here's another one in Laayoune city, where is a controlled landfill and where electric energy is also produced by biogas. So this is a second example. The third one is very interesting and excited one, because it's talking about a startup. Kilimanjaro Environment. Kilimanjaro Environment, it is a startup. It begins in 2008. And their mission, their issue is to transform waste into value. And the most important, it's about to transform the cooking oils in biodiesel. And so the business model is a business model of a startup. It begins with small equipment, but it was a very innovation. It's a very interesting innovation. Why? Because Kilimanjaro developed a collaborative integrated platform for households waste management and recycling. The idea that the EcoGest, they create this platform to collect from households the oil cooking and transform it to biodiesel, which is exported to many countries in Europe, Italy, Portugal, and also in Latin America, in Chile. So he starts at Casablanca, and now he employs, you have more than 100 employees in its startup, and he is active in Casablanca, but also other cities as Tangier and Marrakech. So we can, if you, for example, if you go to iOS or Google Play, we can upload the EcoGest application, and they design one for professionals, for restaurants and hotels, and another one for households. And the idea that we have collectors that make the tour to collect this so the oil, and he takes, so for the restaurant he's paid about $0.50 for each liter of oil cook that he collects. So it is interesting business model. So finally, as I conclude with 3 examples in Morocco. One example of a multinational company, another one which is the fruit of a partnership between public and the private sectors, because it's about a local community, okay? And the third one is about a startup. It means that the concept of circular economy can be applied at multi-levels, okay? And another fact which is very important is that a lot of companies mix and practice circular economy for its economic benefits, but they're not aware that it is a circular economy. So they do it by need, and it works very well. And I think that we can improve, of course, more. If we improve the infrastructure, we can have a high effects of such an approach, and to also to honor our commitments in terms of reducing greenhouse gases. Thank you for your attention, and I welcome for the questions, ready for questions and exchange. Thank you very much, Professor Mela.
Okay, thank you very much, Professor Shraivi. So it's time for questions. Yes, the moment for question is open. Wait for your questions. I can start saying that your proposal is, or the climate change is quite demanding in order to design out the policies to face these challenges. Yes. The adaptation, bearing in mind that this adaptation is quite demanding, bearing in mind that it needs changes in technology, in public policies, private attitudes, the territory management in terms of, for example, the urbanization. So the question could be the one like that, saying that in your view, your opinion, what's the main priorities to face these challenges in areas like technology, for example, or even territory, or different attitudes of of people, no?
Yes, thank you for the question. In my point of view, I think that the priority is education and training at all of the levels, because as I said, that for example, many of companies doesn't know the importance of the approach. And when, for example, I make some conferences or some seminars with the companies, they are very interested, and they say that it's very interesting to say that we didn't know this, and that I think that so informing is very important. When I say also education, it's also to change the mindset of the producer and also of the consumer to produce differently. And I think it is because generally when they are the vision now today, the problem is not only for budget. Yes, there is budget, but the idea is when you have budget, how you can manage differently your territory or your manner or to produce products and goods. So training is very important. Another thing, challenge is to create competencies. Engineers and masters should also have a general point of view of the approach, and not only for engineering. An engineer today should have also courses in economy to understand what are the effects and how you can earn and profit, and to quantify profits also of such a policy. So we cannot isolate technology and engineering also from economy in such approach.
Okay, thank you, Professor. So next one.
Yes, there is a question. And thank you for the presentation. And we are so pleased of the presentation that you did. But there is a question. Some of the time, we usually understand that there is a limit to circular economy. So I would like to know what are the limits of circular economy, and especially in developing countries. In developing countries, they usually say that people are not they are not ready to accept the products that are from waste. Okay, they usually not accept to use products from waste or that have been recycled. So I would like to know what are the other major problems or limits of circular economy in developing countries. Thank you.
Thank you for your question. For industry, I think, of course, there are always limits, but the limits are always that depends on the context. I say that the circular economy is a systemic and a contextual approach. We want to, for example, to apply a project of circular economy in Morocco or in any other country in Africa.
DRC.
It's different
Yeah.
from, yes, it's different. Why it is different? Because, for example, in developed countries, the industry is already here. Okay, so
Yes.
it is difficult sometimes it's difficult to make the transition, and this is one of the challenges today. One is late to make their commitments in climate, in reducing emissions, because the problem is how to make this transition, because all the infrastructure is already here. Okay, but
Okay.
at the same time, I say that, for example, in developed in some many European countries, recycling waste has been practiced, but less in peoples are in countries in emerging in emerging countries. But I think, but what is the opportunity if I talking about, for example, my country or many countries in Africa? That is, we have this opportunity because we can build renewally a new approach and circular economy approach, which is very important, because we are not in a transition, we are building. So we can build from to avoid many errors of the linear economy constraints and to go in a circular economy approach directly.
Yes, and there is still another question about creating an industrial symbiosis. Most of the time, the waste that we have in our country, and especially in our city of Bukavu, the waste come from imported products. It means where the waste have been manufactured, they have not took the context of our country or of our town in recycling. So how can this industrial symbiosis be created? Meanwhile, the waste that we have are from another country or have not been manufactured in our town. Thank you.
Yes, I think that's as I said, because I make a slide that I say a way in launching a way in a process circular economy, and I am aware that it's not easy to launch this at the first time. So,
Yes.
for example, the first thing, in my opinion, to do is, of course, as I say, to make the life cycle management of the product, to identify the waste, the type of waste, to make a typology like of waste that are occurred in this city or in this industrial zone. And then we begin. Circular economy is not like a quick solution, ready solution, 100% ready. No, it's something that we can co-create with steps. So first thing, we cannot from the beginning to make a whole solution. But I think, in my opinion, waste, first thing, to identify these categories of waste, industrial waste, and to examine how can be the approaches of the methods to first beginning some recycling actions. If the waste of this company, of this project, important or not, can be an input, okay, for another industry. At the same, also the most important is also the distance in order to be in practice. So the idea is this: is to begin to identify waste mapping, okay, to identify actors that want to get in such approach. Of course, policy of the local community and of the country should help. Legislation is very important also to begin and to launch such a circular approach. And it is step by step. It cannot be at first time efficient.
Solution. Okay, thank you so much, Professor.
Thank you.
So the last question. So,
Hiya, that's from me. Thank you so much for your presentation. I found it really informative. I've just got a question about consumption, really, and business interest, and the issue of the consumption that I think that from what I understand, the circular economy is continuing to prop up. It's allowing us to continue to consume at the level that, well, especially in the West, that we're consuming at, but in a more environmentally friendly way. I just want to understand what the implications this are for businesses and profit, and how that gap can be fixed if they're going, for example, a light bulb's made not to last so that businesses can make profit. If a light bulb is made to last longer, how can a circular economy match the profit which is made by big businesses?
I think there's a problem of connection. Can you just please, do you hear me?
Yeah, I do.
Can you just repeat the question, please? Because I think I have some troubles with the voice, with the connection.
Okay, I'll go slower.
Yeah, slower a bit. Yes.
How do you think the problem can be fixed for businesses who is interested to make profit from making products which don't last?
Mm-hmm. Okay. Yes. You mean that how we can? I think that, behind this, we need a new manner to design our business models. For example, if I understand the question, there is also a discussion about how can business make profit if he make products with a long life duration, lifetime. Okay, and I think that we can get more, because if we cannot have just only this. We have in the business model, it shouldn't involve just this longing the lifetime product, but at the same time, optimization, and also the optimization of the energy also. So it is a complete business model with many of the parameters, and you can show that it is profitable. Why it is profitable? Because customers, if we have at the same time customers that are aware from the benefits of the circular economy, they will choose its product I think that some troubles with, for example, with iPhone, with Apple, was about the duration life of the batteries, and for example, such reputation of these companies, I think it's are being in trouble, causing about this such practice. So I think that's the business model should take in account, of course, all these parameters. We cannot say that circular economy is only extending the lifetime of products alone. I wish that I have answered to your question or to your.
Yeah, thank you.
Professor, there are two additional questions. The first one is, could you comment about blue economy, please? What's the link between circular economy and blue economy? This is the first one. Second one, thank you for the presentation. You mentioned that the circular economy is designed prior to application in a loop. Is it possible to add sub-loops of subcategories on the fly?
On the fly, okay. So for the first question, thank you, Professor Mela. For the question, to my knowledge, so blue economy, there are this concept is linked, connected with the two concepts. We can talk about blue economy, we are talking about economies of the sea. It means resources, sea resources. This is the first concept, and it is at the same time, so we are talking about how we can produce and using sea resources sustainably, with sustainability. This is the first concept. But also lately appeared the concept of blue economy from the economist, the blue Günther Pauli. So Günther Pauli is defending now to design what we call models of economy. Similar, it is like circular economy. There's a lot of similarities of circular economy, but its idea also is to be inspired by the nature cycles, by the biodiversity circles of the products. And so there's a lot of innovation. For example, for the manner how for the raw materials to produce paper from other materials that, for example, trees. So the blue economy has many similarity of the circular economy, but it is most closer to have lots of innovation also and design. It's talking about the part of design inspired by the cycle of natures. So this is for the first question. The second one is, sorry, it's for about fly materials, planes.
Yes, you mentioned that the circular economy is designed prior to application in a loop. And the question is it possible to add sub-loops on the fly?
Sub-loop?
Loops, yes, partial loops.
Partial loops, yes, of course, partial loops. Yes, it's from the model, because I cannot have time to explain all the models. The model is composed from not partial loops, but sub-loops in somewhere. Right. It's like sub-loops, because that depends on what we have as a waste and what we can do as an action. For some products, we'll go to refurbishment or remanufacturing. For others, we need to go to recycling. That depends on the sector. This is important. That depends on the sector of industry, and that depends also of the product that we have. So we can imagine how many type of loops or partial loops that we cannot cause, that we design, we represent by the closed loop, but there is many type of loops in this all loop. Yes.
Okay, thank you very much, Professor Schreiber.
One thing, yes, just one.
Your presentation was very interesting, and not only interesting but inspiring. So thank you again.
Thank you, Professor. And my last word is about, I will, of course, send to you. Thank you for the organization of this training online. I will send the presentation. And in the references, I have interest in reference. It's inspired from Ellen MacArthur Foundation article paper, which is of great importance because they give a lot of examples about such loops and such examples to practice, to make in practice circular economy. Thank you again so much, Professor Mela, for the presentation, for the introduction and the organization of this training online activity.
Thank you to you. So the next presentation is in charge of Jérôme Rose. Jérôme is research director at the Research Center for Geoscience and the Environment, belonging to the CNRS, the Centre National de Recherche Scientifique. So, Jérôme, I pass you the word.
Yeah, thank you very much, Professor Mela. So I will share my screen. I hope everything is working. Partager. Do you see something on the screen or not? Still not.
Not yet.
It's coming. Yeah, I have some issue with Teams. Do you see something? No, I'm not sure. You see.
You can see it.
Okay, so I just put like this. Yeah, so thank you very much again, Professor Mela. It's really a pleasure to be associated to this really nice initiative that you organize and in the framework of Civis. So I'm very happy to have a concrete action, and it's really nice courses. So what I'm going to talk about is related to the impact of renewable energies on the non-renewable resources. And you will see that there is a lot of connection with the previous talk about the, let's say, circular economy. So just because we are in the Civis Alliance or project, I just want to say a few words because we are all belonging to a same, let's say, virtual university. And so maybe you can be interesting by joining our group or doing stuff with us or having courses that can be given by our group. So just my group is, research group is called Sustainable Environment, which is not very original, but we are working on geosciences. And just to say a few words about who we are and what we do in our labs in terms of research. Our skills are much more related to, let's say, bio, geo, or physical-chemical processes and mechanisms that can occur at the Earth of the surface of the Earth. And our expertise is really to characterize and minimize the impact on the environment of the human activities. And so we have an approach which is going from the large scale down to the molecular scale, and we are using a lot nice facilities that we have, whether at the lab or on national or international facilities. The second point I would like to mention is that our lab is associated to a new type of structure that was created at Aix-Marseille University. Aix-Marseille University created what they call institute. Sorry? Do you hear me? Yeah?
Yes. Yes, can you hear you?
So
Yes.
I continue. Sorry, I had an echo. And so, as in any university, as you know, we have faculties for teaching and we have research labs or unit for the research. And now at the institute, at the University of Aix-Marseille, they created the institute with money, with fund, to enhance the link between the teaching, what we do in terms of, in our master program or undergrad program, and to make much more a better connection between our courses with the research we are doing. And what is interesting is that our institute, which is called Mediterranean Institute for the Environmental Transition, so ITEM with a French acronym, we have in our project more than 700 master students that are involved in the project, and our PhD students are coming from different doctoral school, but we have something like 50 to 60 PhD each year that are joining our institute in between the lab and the faculties. And so what we do in our institute is addressing the analysis of socio-environmental changes for this transition strategy. We also are looking at the resource management for the environmental transition, which is really related to what I'm going to talk today, and how the renewable energy need to take into account the fact that we need to manage our resources. And the last axis is related to the risk of society. I mean, risk can be industrial risk, can be climate risk, can be geological risk, or I mean, any kind of risk. And so in that framework, we develop some priority topics like addressing the biodiversity and the ecosystem functioning, or the global cycle of biogeochemical cycle of carbon, for instance, or of course, in Mediterranean country like we are, I mean, in the south of France at least, and of course in Spain or in Italy or in North Morocco or in any Mediterranean country, the question of water resources is a big issue. And in terms of resource management, there is something here which is called resource recyclability, and really the talk of today is related to that topic. Okay, so it was a long introduction, but so what is the starting point of those renewable energy development? I mean, I'm sure now you're much better than I am in terms of understanding all those technology, but and maybe the history. But of course, I'm sure you all have in mind some images that really are at the beginning of this strategy to jump our economy to this renewable energy is really related to the climate change and the global warming. And so here you can see just few images of what we have in France, for instance, a glacier, and you see the picture from 82 to 2005, and then more recently you see that, of course, those glaciers are, I mean, decreasing in terms of size, and you have many other examples. For instance, this one on 100, even less than 100 years duration, you see that the change are really drastic. So I'm sure you have other images of the global warming to really better understand what's really it's going on. And this, of course, average in temperature is increasing. And is there a global average temperature rising? The answer is, of course, yes. And if you take a time scale of 1,000 years, for instance, which is not very long in terms of history, but if you take a zero in the years between the 1960 to 1990, you see that before the 19th century, the 20th century was really lower, and now you see the red curve, where, of course, I mean, you know that the temperature is really increasing. And if you do a zoom, or if you just look at the hottest years, the 15 hottest years occur since 1990, and those data are didn't take into account the last 10 years, where in fact it was even worse. So I mean, you know that. I just want to make a brief digression about the Mediterranean zone, because it's really a zone where we do a lot of research. And it's even worse in the Mediterranean area, because as you can see here, the curve of temperature in the Mediterranean area compared to the rest of the planet, you see that the warming in the Mediterranean area is warming 20% faster than the rest of the planet. So the Mediterranean area is even more sensitive to the global change. So, I mean, it's like this. It's unfortunate, but it's like this. So you also know what are the effects of the global warming. I mean, there are many examples of what's going on today. I mean, not only the increase in the temperature, but also, of course, the change in water supply, the rising of sea level, and many others. Why we are having this problem now? I mean, you also know that it's related to the greenhouse effect. And so I don't want to go too much in the detail, because I'm sure you know all of those aspects. The fact that we have some gases like CO2, which is the one on which we discuss a lot, but there are other gas that also are contributing to this greenhouse effect, like methane, the CH4, which is even worse in terms of greenhouse effect. And so if you take let's say geological time, like the last 10,000 years, you see that it was changing, of course, but as you see on such a time scale, if you look at the last 100 years, it's like a vertical jump of the CO2 or the methane. If you zoom a little bit, I mean, it's not a vertical jump, but it's really, really strong. So what can we do to mitigate the warming and the climate change and all those global change? Of course, we have to play and to decrease the quantity of CO2 mainly, but of course all the greenhouse gases, because we know that the level of those gas is really, really causing the temperature rising. So in fact, what is clear is that if we take just into account the carbon dioxide, the increase really started the past century, and it's really related to our human activity. It's not really to it's not related to non-human activities. And so we have to find a way to reduce the amount of carbon that is fossil carbon, but carbon that is emitted. And of course, I mean, you know, after the courses you had since Monday, and you certainly are better expert than I can be on all those renewable energy, you know that we have a lot of possibilities, and we have a lot of energy that can be renewable and can be very efficient. And maybe you have this kind of information in mind. Sorry, some of my picture are in French, so I will try to translate. But if you look at the technology and the emission of CO2, so the emission direct, it's direct emission of CO2 during the use of technology. Like if you take a wind turbine, of course, there is no CO2 emission during the use. If you take a solar panel, that's the same. Hydraulic dam, it's also the same. Nuclear energy, you know that in France we have a lot of electricity that is produced by nuclear energy, it's zero. And of course, if you take the example of coal, natural gas, or oil, you generate CO2, and for instance, more than 200 grams per kilowatt that is produced. If we make a connection with the previous talk about the circular economy and the life cycle of product, we have also to take into account the fact that if you want to develop a solar panel field, you need to make those solar panel. And so if you take into account the making of the object, the use and the end of life, of course, the scenario is a bit different, because if you take the wind turbine, for instance, there is CO2 that is emitted during the whole life of this technology, but I mean, it's low compared to coal, natural gas, and fuel, which is even worse when you take into account all the life cycle of the technology. So those technologies are very efficient in reducing the CO2 emission. And why do we have this CO2 emission? It's of course because the population is growing since since all the time, but is really growing even faster during the last 15 years or the last 50 years. You see on the curve whether the energy production or the gross world product increase and the agriculture production is really correlated to the growth of population. And now if you take, of course, the production or the emission of carbon dioxide from the fossil fuel, with coal, natural gas and oil, you see that of course the curve exploded after the Second World War. So after, let's say, during the 1950s, and it's continuing to increase. And on that curve, if you add the non-renewable energy, you see that they are on top of this curve. So the proportion is really, really low. And you see the curve is not that old. I mean, the data are coming from 2017, so just 5 years ago. And the change today are not that much. So the proportion of the renewable energy in the total world energy consumption still remain very low. And if you look at the projection, what we have to do, what we should do, and if you look, for instance, at the agreement in Paris in 2016, the COP21, and the scenarios that try to predict what should be the trajectory, the transition to this renewable energy, all the scenario, of course, rely on a strong increase in solar, for instance, wind energy, and all those energy. And here you have some quantification of those needs, and you see that the increase from today, 2020 or 22, in the next 10, 20, or 30 years is a multiplication by 4, 5, 6 compared to what we are generating today. So it's really a strong increase that is really necessary. But of course, at the same time, we need to have we need to think about what do we need to do that change from fossil fuel energy to renewable energy. And in fact, we need material, we need resources. For instance, on that curve or on that table, you see for, let's say, a new generation of wind turbine like 6 megawatt, which is a kind of a big object, more than 100 or 200 meter high, you need 1,500 tons of steel and for one turbine, and you need more than 100 kilo of rare earth element. And now, so on the curve, you see that for the wind turbine, the steel capacity per so the ton of steel needed for megawatt is 250 compared to other type of energy like the hydroelectric energy, which is only 20, and even nuclear is only 60. So here it's clear that if we want to convert our non-renewable energy production to wind turbine or solar panel, we're going to need a lot of metals like steel, for instance. And so our colleague Olivier Vidal, and I send you a paper from Olivier Vidal, a more recent paper with a lot of data on what do we need in terms of natural resource like metal or cement. So Olivier did the work something like 10 years ago, and the paper I send you is a review, an update of this paper. You see that whatever material you take, like concrete, aluminum, copper, glass, if you want to do this transition to the renewable energy, the need will be increased by something like between 2 to 8 times compared to what we were to the all world production in 2010. So which is clear that only the renewable energy will take let's say on average 5 times more material that all that was produced in 2010 for all the technology. So it's really a huge need for the year to come. So let's make it clear if we think about this energy raw material nexus. So it's clear that we need metals or we need material to produce energy, and whatever energy, but of course also non-renewable energy. And we also need energy to produce metals. What I mean is that if you want to produce cement or steel, you're going to need energy. And so, for instance, it's clear that in 2011, 21% of the global energy consumption in the by the industry was used for the production of steel and cement. And if you look at the energy consumption just for mining, so taking the metal to produce the wind turbine, for instance, the increase of this technology or the increase in energy demand for this mining activity is increasing each year by 6%, which is more than all the increase of the economy worldwide. Another example, 1 ton of carbon dioxide is generated for 1 ton of concrete of cement that is produced. And if you take the example of steel, 1 ton of CO2, 2 tons of CO2 is generated for 1 ton of steel that is produced. So those data need to be taken into account when we want to do the conversion from non-renewable energy to renewable energy. Here, so sorry, the curve is a kind of a mess because there are too many curves, but just to show you that it's the case for all the metal, all the elements that you can imagine, we know that the need is increased. And those are data, those are not projection, because you see the curve ended in 2015. So during the last, let's say 60 to 70 years, the increase in terms of demand for the rare earth element, for instance, the violet curve, the need were multiplied by 10 since 1960. So by 30, sorry. If you take neodymium, for instance, which is used in a wind turbine, for instance, it was multiplied by 20. So it's not only an increase, it's really a huge increase. For instance, indium that is used in many technologies was multiplied by 13. So the needs are very, very important for those new technologies and energy technologies. So the challenges we have to face are very important, and they are related to the demand. So how can we anticipate the demand? How can we also control the demand? The second challenge is related to the supply. Is there the possibility to supply and to provide all those elements for the new technology? We also have to face another challenge, is that the resources like the metals are not distributed in all the country. Some countries are very, let's say, rich in terms of metal because they have mine in their country, and some other country, like in fact many of the European countries, were very poor in terms of those elements because the mine were exploded and now they closed. We also have to face the fact that mining activity is requesting a lot of energy. So we have to find other way to extract the metals from the mine for the ores. There are also two other challenges that are very, very important to take into account, is that we need to take into account the environmental and the social impact of all the needs in terms of metals or element, because we cannot open a number of mine anytime, anywhere, without any control of the environmental and societal impact. And the last point, which is much more related to the prospection, we have a lack of data in terms of geological data, which by that I mean that we don't know whether the resources for many metal can be increased or not, because we need to continue the prospections, which is also energy demand, but also very costly. And so if you look at the elements that are of concern, if you take, for instance, the wind turbine, the element or the metals that are required are, like, for instance, rare earth element like dysprosium, neodymium, but also, let's say, much more traditional metals like manganese, copper, or even not metal, but element like concrete, because generally the basement of the wind turbine are made of concrete. And so if you look at the lifespan of those technology, a wind turbine is sold for a lifespan of something like 25 years, which means that all we are doing now by developing this technology, we know that in 25 or 30 years from now, we're going to have to refresh everything. So to dismantle or to update or to change. So the need will not stop. And so we have to take into account that the lifetime of those technology. If you take the solar panel, is also the same type of lifetime, between 25 to 30 years. So in 30 years from now, all the solar photovoltaic solar field that we have, I don't know whether in the south of France or in Spain, will have to be renewed. I mean, we dismantle and refresh. So again, a lot of material will be needed. I'm sure you have heard about the term like critical element or strategic element or metals or emerging metals or high-tech metal. Those terms are, you can find those terms in the literature. They are not very, I mean, they are similar, but some differences exist. The point is that if you take all the definition, all those elements, the common point is that all those elements have a high economic importance, not only for renewable energy, of course. So let's take the definition of critical metals. The critical element or critical metals have 2 points in the definition. First, they are strategic for a country economy by the fact that if we have a lack of those metal, it can affect the competitiveness of a country. And the second point is, of course, the risk of supply of this metal or of this element. And clearly, the definition of critical metal depends on the country. Here you have the table where you have on the x-axis the economic importance of a metal, and on the y-axis the supply risk. And this table was defined for the European countries. Of course, if you take the American, the United States, the type of element will be different because it depends on the mine you have in your own country. But you can see in the case of the European countries, we are depending, I mean, the list of critical metals is very high, or critical elements is very high. And so we are depending on other countries for those elements. And those critical metals are, of course, really, really important for the wind turbine, for the photovoltaic panel, so of course for the renewable energy. And in connection to the renewable energy, of course, we have the transport, so the electric car. And so the element like neodymium, dysprosium, gallium, indium, selenium are very, very critical for this new technology for energy production. Oh, okay, so that's almost the same type of slide with other technology. Like for instance, you can include thermo emitters for the thermophotovoltaic. I don't know whether you have courses on that, but this technology is also an emerging technology where we need a lot of tungsten, for instance, which is also considered for the European countries like a critical metal. The other point is that, in fact, what is interesting, if you look at the history of industry, if you take the list of critical elements, in fact, the need are very recent. If you look at, for instance, for the last, let's say, 7,000 years, of course, an element or metal like copper was used by the civilization for thousands of years, and we have a lot of history of how to recycle, to use the copper, and it's used for a really long time. But if you take the rare earth, for instance, the story is very recent because the rare earth element were really exploited like the last 20, 30 years. And so the mine really opened recently. And so that's really important to have this in mind also, because and it's related to one challenge I mentioned. We have a lack of geological data on those elements because, of course, the geologists, they started to be interested on those elements very recently. So the prospection was not the same, like in the case of copper, for instance, where I think we know in any centimeter square of the planet where we can find copper, which is not the case for those other elements with a more recent interest. And if you take also the data in terms of apparent consumption of world production, just look at the green curve at the bottom of the graphic. This is gallium, and you can see that even after the 2008 crisis, the increase of gallium is kind of vertical, and the gallium is used in new technology, as you certainly know. And so the increase is really very, very recent, the last 10 years. So for some metal, we have not a long history of prospection and geological knowledge. But not only those elements are I mean, recent in terms of use, and we don't have enough data in terms of where they are located, but of course they are associated to societal and geopolitical impact. As I mentioned, not all the countries are on the same situation in facing those elements. For instance, if you look at our friend in China, their resource, the concentration of resource of rare earth elements that are very strategic is at 95% in China. Whether it's located in China or whether the Chinese company bought the mine in other countries. So 95% of the rare earth market on the planet is controlled, let's say, by China or Chinese company. You can take other example like, for instance, cobalt, where it's much more in African countries that the resources are located. If you take lithium, you know that lithium is whether located in the South America, like in Chile, or in Australia too. So those two countries will produce, I mean, all the lithium for all the planet. And of course, it can be not only societal, because when you have mining activity, generally you may have some environmental impact, problems, and of course it can affect the society around or the city around those mining activities. But of course it can be a geopolitical impact. I don't know if you remember between the previous American president and when the crisis between United States and China was quite high 2 or 3 years ago with Trump, the Chinese government decided to stop the selling of rare earths, and in fact the prices was multiplied by 2 in 2 weeks. So I mean, the consequences can be very, very high. And unfortunately, in many cases, not, of course, not all, it's not the case for all the metal, but in some cases, the metal are coming from country where a conflict exists, whether a war, and so when I mention societal impact, it's of course even worse in the country where you have a conflict, and the minerals are generally really at the center of the conflict, because in terms of money, it's a huge, it's a huge impact on the country. And it's unfortunate, but we are using those metals, and indirectly we contribute. I mean, of course, it's not what we want, but because we need those metals, the conflict continue because of that. Okay, so the panorama is not very, let's say, optimistic. So yeah, then what can we do? Okay, can we reduce the human pressure on the strategic resource, even because we need that in the convention of energy and for the on the renewable energy, sorry. And how can we reduce our dependency on producing country, which is a question that the European countries are asking, but not, of course, the China or the African countries. The difference between oil and gas is that metal or element can be recycled. And so, of course, initially they come from a geological reserve. We extract, we produce the metal, and we produce the goods like, I don't know, wind turbine or plane. And at the end of life of those technology, we can recycle element, which is really important to have in mind. And that's why I said my talk is related to circular economy, because we need to have a circular vision of the cycle of element. And so in the idealistic world, where we can recycle most of the element, it would be possible to have a let's say, theoretically, an endless story. In the case of steel, for instance, where the recycling is really high, I mean, we can imagine using steel for years and years if the demand will not strongly increase. Because, of course, now we have, let's say, a stock of steel that is used in technology that we can recycle when the technology is ending. But of course, if the demand increase, we will need to continue the extraction from geological site. If you look at the percentage of recycling of many elements, in the blue color means that more than 50% of the element is recycled. So, which is a good percentage of recycling. So let's take, for instance, iron, which is a very common element, or copper. I said is used for years and years. So for those elements, the recycling is higher than 50%, mainly because we use those elements for years and years. And so the technology for the recycling is now mature, and we have a good efficiency in the recycling. Of course, for metallic element with magnetic property, for instance, of course, like iron or the magnetic element, the recovery can be facilitated by the magnetic technology. You can recover iron from a lot of waste, so you can be efficient. But as you can see on the red color, which is below 1%, it's the case for the rare earth element. So the line at the bottom of the slide, and so it's also related to the fact that we use those elements just since 30, 20 years, and so the technology is not mature even for the extraction, for the mining technology. And so you can imagine for the recycling, we need more maybe more time or more investment. And so the history tells us that the concentration that we recycle is very, very, very low, and it needs to be strongly improved. So there are many solutions, of course, and I will focus on just one type of action we can do, and something that we do in our lab and at Aix-Marseille University, but I'm sure is done in other universities in the Civis Alliance. It's, of course, trying to extract or to exploit secondary sources, and we call that urban mining. I don't know whether you are familiar with the term. Why we use this term? Just let's take the example of smartphone. I don't know whether you know how many billion of phones are sold each year, but in 2017 it was 1.5 billion. And I don't have the data for this year, but I'm sure it's much more. And we took the example just of France. Currently, only 15% of the phones are recycled. or we use because they can be refurbished, but the percentage is quite low, only 50%. And in terms of recycling, when you dismantle a cell phone, so you don't reuse them, but you destroy the phone and you try to recover the element inside the smartphone, the only elements that are of interest are gold, silver, and in some cases copper. So most of the other elements are not recycled at all. And so you can imagine that in the waste of those cell phone, it's kind of a new type of mine, because there are many other elements that can be recycled and that they are not recycled today. We can take many other examples of waste. Just for instance, let's take the example of wastewater treatment waste. We call that a sludge. I'm sure you know what a sludge is. Generally, the odor is not that very good. And some colleagues, they try to quantify the metals that were in those sludge, and try to quantify the amount of money we are losing in fact, and it's quite important, because we are losing almost $300 per ton, which is substantial. I want to show you another example, which is related to a mining activity that was related to our local area in France, in the south of France, close to Aix-en-Provence or to Marseille. We used to have bauxite mine. I don't know whether you know what the bauxite is. The bauxite is the ore to produce aluminum. And so we used to have this technology. So the mine now are closed, but we still continue to do the recovery of aluminum from the bauxite. The bauxite is coming from Africa, from Guinea. But now we have a lot of waste, and the waste of the bauxite, so aluminum extraction from bauxite, is called the red mud. Red, you know why, it's really red. And so that's what I show you is the waste from this technology. So what are the issue? Of course, we can find technology to recover metal from a mining waste, which is the case of this bauxite residue. It's a waste from the mining and the metallurgy extraction. So we have technology to do that, but we need to change that, because as I mentioned, the energy consumption from the mining activity or the metallurgy activity is increasing. And so if we continue like this, if we don't change the technology, we will not be able to sustain the recovery of metal. For instance, up to now, the extraction of metal from a rock or even from a waste is used by hydro or pyrometallurgy, which means that in fact you have first to dissolve your rock with a very strong acid at pH 0. So a huge amount of material, you dissolve the rock, and then after that you have a high temperature process. High temperature, I mean higher than 1000 degrees. So you need a lot of energy, of course, to reach that temperature. So the technology exists, we can use that, and they are used now, but we have to find all the way more sober, or having a sobriety in the way we try to recover the metals. So what we try to do is we try to find, of course, technologies that are, compared to traditional, as much, we try to reach the same efficiency. It's difficult, because if you use a lower amount of energy, the efficiency of extraction generally, of course, decrease. So we have to find some chemical ways to improve the extraction efficiency. In the same way, trying to reduce as much as possible the impact on the environmental impact or the energy impact. And so just few results before the discussion. Here you see a curve where, as function of the pH, we have the percentage of element, and here you have a list of rare earth elements like lanthanum, cerium, neodymium, or gadolinium, even aluminium, because of course this weight is coming from aluminum extraction. So aluminum remain in the waste. And so as you can see, we were able to find a pH zone between 4 to 6, which is not a strong acidic condition. If you remember, just a few minutes ago, I said that the traditional technology use a strong acid and a lot of acid, and the pH is not 5 or 6, it's 0, even below 0. So it's very, very acidic and very and the impact on the environmental environment is huge. So here we found a way in a pH range close to neutral pH, so not that acid, where the recovery for some element is not that bad, up to 60, 50%. So of course it's not 100, but it's not that bad. And in the example, we didn't increase the temperature. So it was made in water, just at room temperature. So it means that we can find very soft, let's say soft chemistry or green chemistry processes to recover elements that are very important for renewable energy in a way that is not impacting the environment. Of course, 50% extraction is not enough. We need to increase the let's say the selectivity. And so we're trying to find some ways, and we try to look at how the biology is dealing with metal. And it's interesting because if you look at living organisms, there are some plants, for instance. So the first plant is Dicranopteris linearis. So sorry for the name, but you see the first plant on top of the image. This plant is what we call an hyperaccumulator, which means of rare earths, which means that if you measure the concentration of rare earths in the leaves, it can reach 1,000 ppm, which is huge. If you do the same in a traditional plant, you will find just few ppm, and here is 1,000 more. So if that plant can, let's say, extract rare earths from the soil, maybe it's because there is a specific chemical compound or specific mechanism that can enhance the concentration of this important element in the leaves. So if we understand how it's done, maybe we can develop a process, a chemical process, by taking the right ingredient to improve our own process. And so you can find also like bacteria, like Pseudomonas, where there is one enzyme has been identified as very dependent on lanthanum. And so by using this enzyme, maybe we can also improve the efficiency in terms of recovery of rare earth element. And there are also other organisms like a sponge, and there is the name, so Oscarella lobularis, where in this sponge you can find a bioconcentration of vanadium, which is very, very surprising. And so this sponge can do something with vanadium, and we want to understand how the vanadium is stored in this living organism to try to reproduce this, to mimic this organism. Okay, so I'm close to the end. So as you understood, we need a lot of metals to do this transition in terms of going from fossil fuel and fossil energy to renewable energy. And if we want to do the full conversion, we will need for sure to recycle and to recover those elements from waste. And we need to have this recycling technology to be more mature, and we need to invest a lot. And this recycling is not only, of course, a good opportunity for the renewable energy, but it's also going to have a lot of a social importance, because of course, if you can recover metal from a waste, it means that you are reusing a waste, and so you don't need to store the waste, because you convert a waste to a resource. And so of course you reintroduce the waste in the industry, and so you don't need to have a huge place where you store something for years and years. You reuse it. And of course, when you have in some cases, when you close a mine, of course, it has a strong societal impact, because of course, a lot of people are unemployed, but also, of course, you also, unfortunately, have a lot of health impact on the population. And so if you are able to reintroduce those waste in industrial cycle, then of course, you use that and you don't need to store the waste anywhere. Okay, so I really want to conclude with positive vision, because of course the situation is, but as you see, we can find ways to try to improve the recycling, and we find ways also to decrease our needs in terms of energy. And so sorry, the last slide is French, but it's showing young student really strongly motivated to change the way we live and to change the way we use energy. And so I'm very confident by the new generation that are coming, and so you as a student, to find good solution and smart solution to improve our efficiency in this energy transition. And with that, I would like to thank you, and of course to start the discussion.
Thank you very much, Jerome, for your inspiring lecture. And yes, it's time for questions. I can start with one quite general. Bearing in mind that the industrialization processes, urbanization, the transition to low carbon energies, and so on and so forth, are raising questions, really profound questions about the sustainability and the condition of supply of raw materials. Would you mind explaining a bit more the trends of the projection in the coming decades of the consumption of mineral resources and energies?
So yeah, the paper I send you from Olivier Vidal is very interesting, and if you can look at the other paper from Olivier Vidal, it's really important because this guy is coming from geology and really from mining activities, and he proposed different scenarios, or he compared different scenarios. For instance, you can compare scenario where you consider, for instance, like you have 50% of recovery or recycling of metals. You can compare a scenario where you have 90% of recycling. But all the scenarios that Olivier tested failed in the next, or of course, depending on the proportion of recycling, it can be in the next 20 years or 30 years or 50 years. But by the end, for all the scenario, if we don't change the increase in the energy demand, we will not have enough resources from the earth. And even if you recycle, because as you know, the recycling is never 100% because you lose in the processes. Sometimes when you have a material which is complex, if you take a smartphone, you have so many elements in just a tiny pieces of object that is very difficult to recover the cobalt from the iron, from the rare earth. And so we know that the recovery will not be 100%. So we need to improve the efficiency of recycling and recovery, but also we need to decrease the energy demand of all the population, which is, of course, not a scientific issue, but it's really a political and a societal issue. And if we all together continue to use or increase our use of energy in the 20, 30, 50, 60 years from now, we're going to reach the wall because we will not have enough resources. Let's take the example of indium. It's the next 15 years. I mean, the best prediction are we will not have any new indium from the earth in the next 15 years, which is tomorrow. So yeah, it's a bit, let's say, negative, but the positive point is that if we change the way we use energy or our demand on energy, we have the power to extend that problem in a longer period of time.
Apart of the effects of the geopolitical terms.
Yeah, exactly. Yeah.
Because the localization of these raw materials are very concentrated in the world.
Yeah. That's the biggest issue because the ore are very, as you said, concentrated. If you take copper, I mean, the number of mines where the copper is produced today are less than 5 in the world. I mean, the biggest in America, North and South. And so if just one mine is closed, I mean, you decrease the quantity of copper on the market by 40, 30, 20%, and the price jump immediately.
Right.
Maybe you know, if you take all the elements, aluminum, copper, it was due to the COVID. But I mean, those days, the price of all the metal increased by 20 to 200%, depending on the element. So it's huge those days.
Okay. Go on. Any other question, please?
Yes, there is a question. So I say thank you to Mr. Jerome for the presentation. And there is still a question that remains. In the coming days, maybe years, in 20 or 50 years, if we begin to use renewable energies, does it mean that in those years there will be no longer be using non-renewable energies? Does it mean that the use of renewable energy will exclude or will end up the use of non-renewable energies? And when you were talking about the materials that we use for producing renewable energies, for instance, the cobalt. We nowadays know that DRC, the Democratic Republic of Congo, has a potential production of cobalt. So, what will be the place, or what will be the role that will play Congo in the energy transition in 20 or 50 years coming? Thank you.
So for the last question, the situation of this country will be very strategic for many reasons, because as you said, because the cobalt is very located in this country, or in few places, of course, and because we all need this cobalt, I mean, in all the industrialized country, the place of the country will be strategic. And as Professor Mella said, it's going to be a geopolitical issue, because if, for instance, this country decided to increase the price, I mean, everybody will support the price, and so we have to pay that. And so a country like European country, where the technology is developed, will depend on mostly African countries or South American country or China, because there is a lot of resources there. So clearly, the equilibrium between what we call the rich country or the developed country will certainly be changed in the next 10, 20, 30 years, because let's say the power of a country will change. And now we talk about the industrialized country, they will not have the power because they will not have the resources. So that's why in European country, recycling is vital. We need it. But of course, in African country, you need to sell. And so it's a bit different. So you said that the conversion from non-renewable energy to renewable energy will not be immediate. It's a kind of transition. And for instance, now to produce non-renewable to produce renewable energy, we need non-renewable energy. But because, for instance, if you look at how the mines are working, they use oil, gasoline, tractor, and stuff like this, excavator, and they are not electric, and so they need oil. So it's non-renewable and fossil fuel. And so the transition is important also because, I mean, certainly now you know it better than me, but also the problem with renewable energy is that you need to store the energy. Well, it's not the case with oil. You just store, you have a tank of oil and you use the oil when you need the energy. With wind, you produce when you have some wind, but if the wind is during the night, you don't need energy, you produce energy. And how can you store it? And so that's why the two technology will not convert from one to the other one instantaneously, and there is a transition period. The question is, how many time do we have the transition between continuing to use non-renewable energy and the development of the renewable energy? In France, for instance, one of the issues is increasing the quantity of nuclear energy for electricity production. So nuclear energy is non-renewable, but it's important because it's not producing CO2. So it's a kind of compromise. But yeah, we know that it's really a transition. The question is how many times the transition will last, and we don't really know. There are several scenarios.
So thank you so much. Thank you for the answers, and thank you.
Is there other question?
Yeah. Any other question? Okay, so thank you very much for your wonderful presentation. It was very attractive. So.
Thank you, Professor, for the initiative. It was really great.
Because he asked for a deep research, because it's quite challenging, all the questions that you present in this session. So keep in touch, and
yeah, we need your student to help us.
okay, so
thank you.
it would be great that you send your presentation, because
okay, I will do that. Yeah,
we appreciate it very much. So thank you very much again, and have a good day. And see you tomorrow. And we could, because tomorrow will be our last day of the seminar. So thank you.
Thank you very much. Have a good day. Yeah, bye bye.
Bye bye.
Hola, José María, podemos cerrar ya la sesión, ¿verdad?
Sí, yo creo que sí.
Estupendo. ¿Está Luis por ahí? Porque ahora hay que generar el listado de participantes.
Sí.
¿Está Luis por ahí o no? ¿Conectado?
Sí, yo estoy...
Tú estás, vale. ¿Quién ha iniciado hoy la reunión? ¿Has sido tú o ha sido Luis?
La reunión. Bueno,
sí.
yo entré como todos los días.
No como sé todos los días. ¿Y estaba conectado Luis antes o estabas conectado tú el primero?
Sí, ¿no? En realidad creo que fue él, porque yo no le di a recording has started y
vale.
ya había empezado.
Vale, pues vamos a ver si tú puedes sacarlo, porque es que técnicamente es Luis quien, si se ha conectado primero desde su ordenador.
Yo no sé si estará... Dime para...
de la pantalla verás que hay un icono que pone participantes.
Show participants.
Sí, y ahí te salen 3 puntitos donde puedes tú descargarte el listado o no.
Show participants. Vamos a ver, yo veo todos los participants y los puntitos están abajo de todo, ¿o dónde están?
No, los puntitos tendrían que estar a la derecha de donde pone participantes.
Sí, more actions, ¿no?
No, es que el listado está en el área donde pone participantes.
Ah, está listado. Sí, yo tengo aquí vamos a ver, el listado de participantes, ¿sí?
Vale, o sea, pero en la propia aplicación de Teams me refiero, ¿te sale ahí?
Yo pincho en donde pone estos muñequitos, ¿no? Estos.
Te saldrá como...
Un listado de nombres, sí.
Exacto, sí, pero te sale el listado que tú ves, vale, pero a la derecha de participantes te sale también 3 puntitos que pinchas y te pone descargar listado o no.
Aquí tengo 3 puntitos, pero es a la derecha de
la mano y del icono, ¿no?
Sí. En los 3 puntitos, Alba.
Sí, es que hay puntitos,
bueno,
o sea,
pues
quien abre la sesión, vale, y en los 3 puntitos, ¿qué te sale?
En los 3 puntitos sale device, call, meeting, gallery, together.
Vale, eso es porque Luis ha abierto la sesión y es él quien se podía descargar el listado. Pero bueno, lo arreglamos, registro en algún otro lado, pero es Luis
espera,
porque...
Le voy a llamar ahora, porque me dijo
si...
que podía llamar. Sí, espera un momento, vamos a ver. Le voy a llamar por el móvil, vamos a ver, Luis. A ver.